Hi everybody. I had a question through on email about the exercise we did yesterday. I think it was yesterday, which is exercise 5b, solving the trigonometric equations. People were able to find the first principal value, but they weren't sure how to use the graph to find the other values. So I'm going to have a quick go at one question. It's exercise 5b, question 5b. Sorry, try that again. It's exercise, it's not 5b at all, is it? It's exercise 5e, and it's question 5b. And so I'm going to have a quick go at this, and hopefully just doing an extra example will deal with the misconception or the lack of knowledge about how to do this. Okay, so we've got 5 sine 3 theta plus 3 equals 1. And we've been told from the question that theta is allowed to go between 0 and 2 pi. So first of all, if you can rearrange this equation to get it into trigonometric function equals something, then we'll be on our way. So I'm going to take the 3 off first to get 5 sine 3 theta equals minus 2. And then I can divide by 5 to get to sine 3 theta equals negative 2 over 5. So sine of something equals this. At this point is where I'm going to make my question easier. I'm going to substitute x in for 3 theta. So I've got sine of x equals minus 2 over 5. And thinking about this, so if I want x to be in the middle, I need to times this by 3, so I have to times the endpoints by 3. 3 times 0 is nothing. 3 times theta is 3 theta, which I'm now calling x. And 3 times 2 pi is 6 pi. Okay, so I've got sine x equals minus 0.4 minus 2 over 5. And if I plug that into my calculator, making sure that I'm in radians, that's what we've got. Inverse sine minus 2 over 5. So I get negative 0.411, etc. Okay, so there's a few things to note straight away. Excuse me. So the first thing to note is that this principal value is not within the range of x. Okay, x is allowed to go between 0 and 6 pi, and this is outside it. So in our final solution, we're not going to include this value. However, we are going to use this value to find out what other values of x will be in this range. So if I now draw myself a sine graph, and because this is going to be a negative value of x, I'm going to draw a sine graph which goes into the negatives, and I'm also going to draw it up to 6 pi because I want to do between 0 and 6 pi, but because there's negative bits here, I'm going to go negative as well. I probably don't have to go very negative, so I'm just going to do a half phase back. And then that's 2 pi, 4 pi, this is getting worse, and then, oh crap, 6 pi. Okay, so sorry about that getting worse as it went on. Okay, so that's 2 pi, that's pi, that's 3 pi, that's 4 pi, that's 5 pi, and this is 6 pi, and this is a minus pi. Okay, so it says x is minus 0.4111, and when I stick that into sine, I get minus 2 over 5. So minus 2 over 5 is going to be somewhere out here on my axes. I'm plugging that value in, and apparently that gives me minus 2.5. So this value here is going to be minus 0.411, dot, 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 dot. When I plug it in, it gives me minus 2/5. And what I want to do is draw a line straight across here and find out what other values for big X would give me minus 2/5. Well, this obviously does. This value here would give me minus 2/5. This value here would give me minus 2/5. This one, this one, this one, this one. So we've got those values that lie within 0 and 6 pi, and I know if I stick them into here, I will get minus 2/5 because it's on this same line going across. So the question is how to find out these, and this can be done by thinking about the symmetry of a sine graph. So at the moment, this is minus 0.411 in from here. Okay, I was at 0 and I've gone back minus 0.411 radians. Via symmetry and thinking about that this curve is like this, that must mean that this one is 0.411 in from there. So in other words, I've got x is equal to, well, I don't count this one because it's going to be outside the range, but this one is pi plus 0.411, and pi plus 0.411 is 3.55, etc. And you'll notice that this is not one of the answers in the back, but that's fine, we'll get back around to that one. This one here is 0.411 less than 2 pi. So I can type that into my calculator, 2 times pi, take away 0.411, gives me 5.87 ... And then I can do this one, that one, this one, and that one, and I'll leave you guys to do those ones. That's what x equals, and x is 3 theta, so 3 theta equals these things, 3.55 ... 5.87 ... But I don't want 3 theta, I don't want x, I wanted to find out what the solutions were for theta. So I now need to divide by 3. So I've still got 5.87 in my calculator, so I'm going to do that one first. This divided by 3 would give me 1.96 to 3 significant figures. 3.55 divided by 3 gives me 1.18 to 3 significant figures. And then obviously I would have, how many values will I have altogether? 1, 2, 3, 4, 5, 6. So you would do your other 4 here, divide them by 3 to get this last line, and you should get what the answer is. Let me double check I've actually got those first two right quickly. What are we on? Exercise 5e. Exercise 5e, question 5b, 1.18, 1.96. Good, fantastic. Okay, so that's how you go about doing this. It's using this graph and thinking about the symmetry of it. If anybody's still struggling with these questions, please give me a shout and I will email me and try and, if you're really struggling with something, have a go, take a picture of your work and email it to me. I might be able to help that way. Or if you're really struggling, we'll organise something else so I can help you a bit more with it. Okay, thanks very much and hope you have a good day.